Hello and welcome to another one of D's ADD videos. Today we're going to be looking at a binomial distribution using the table. I believe the example we looked at before was a probability of getting an A on your stat test, and that was equal to 0.2. The success in this case of Bernoulli trial is getting that A, and you repeat it over and over, and either you got an A or you didn't. And the probability of getting an A is the 0.2. And we're looking at 8 people in our study group, and we want to know what's the probability that 2 people got that value of an A. So in this case, the way that would work, because we're dealing with a cumulative distribution table, what that means is that you have everything in the table is not just that K value or X value, whatever you want to look at it. It's everything from that number and up added together. So if you want an exact value like this one here, what you need to do to get A equals 2, you need to do probability of A equals 2 minus the table value of probability of A equals 1. Make sure that it's a cumulative distribution table. You can usually tell it's cumulative distribution because we'll have numbers for probabilities all the way down and then ends up with 1s at the bottom, okay? Because they all have to add up to 1. So in this case, if we were to look at the group table that's associated with 8, go to the column with 0.2 and look up the X or K values of 1 and 2. Let's do that here. We have a PDF table already set up for us. Nice and neat, yes. So if we come over here, there's the 8 table coming up on your screen. Let me just do that. And then if I go to the probability of 0.2, I would take the difference between this one and that one to get the exact value of 2. And this should match up what we did. If you watch the video for the formula, it should match up with that value. So let's see if it does. In this case, we're going to have a 0.7969 minus a 5033. Let's see if we can remember those values. 7969, 5033. So 0.7969 minus 0.5033. Get your handy dandy calculator out. Point 2936. All right. Let's see. Is that what we got when we did it the other way? Oops, didn't we do that? What I should have done is minimized this. Maximize that. So did we do 2? Yeah, we did, because we had to add it up here. And yes, there is that 0.293 that we got when we did it the other way. So now the question is, can I get back to my table page? Yes, there it is. Alright, so that was what we got. I know it was 0.293, and this is a 6, which will make it 0.294. That's close enough. Okay, hundreds of thousands place, it's still the same. Alright, so now let's look at how to use the table to do part B of the question. Part B was at least 2 computers, or 2A, sorry. So probability of at least, it would be greater than or equal to 2. So on these, you want to use the complement rule again, and you're going to have A is greater than or equal to 2 is equal to 1 minus the probability of A is less than 2, and again, because that's a discrete distribution, that means less than or equal to 1, because that's the next value that has a probability. Alright, now because the table is cumulative distribution, all you have to do is 1 minus the value for 1. In this case, if you look up the value for 1, let's see what that was. 5033, because everything else was the same, right? So do 1 minus 0.5033, you get 0.4967. Alright? So that would be that. And then if you wanted the at most, my colors aren't responding too well. So if you wanted at most, this was at least. At most would be less than or equal to 2. That's just the table value for 2, whatever that is. In this case, that was not the clock. We need the table value for 2 was 0.7969. So that would be 0.7. So you can see that with a table available to you, it's a lot quicker to calculate these values than without a table. Alright, so real quick, let's just do the expectation and the variance. Expectation is n times p, n is 8, probability was 0.2, so that means that there's expected out of the 8 people, 1.6 people would get an A. And then for the variance, that's NPQ. So we will take that 1.6 times it times 0.8. Q again is just 1 minus P. So that would be 6 times 8. Oops. Try that again. 1.6 times 0.8 equals 1.28. Alright, and that's the variance. And if you want the standard deviation, actually in this case it would be S, right? Because we're looking at a subpopulation of a group. And standard deviation would be equal to the square root of 1.28, which would give you 1.13. Alright, so again, if you want exact values, you're going to have to do a subtraction like we did here of the value minus the value before it. If you want at least, use the complement, and whatever you're looking at, when you do less than, it always got to go down one value. And then when you're doing at most, you always look at that value on the table, and that's your answer. Okay, and those are just formulas for expectation, variance, and standard deviation. I hope that has clarified things for you. Make sure you practice, 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 and thank you, and have a nice day.